All right, 9. So let's just take a quick look at what is meant by when we're trying to find the equations of linear relations. So if you remember back to the work that we did with direct and partial variation, um, y can vary directly with x, which means that it goes through 0, 0, or y can vary partially with x, which means that it's going to then go through somewhere else on the y-axis. And so that partial variation comes from things like if you are charging $50 per person for an event plus $800 for the hall, then if no people went, you would still have to pay that $800, and that $800 would be on your y-axis and would be considered a y-intercept. So in this case, whatever the example is that's going on, that initial cost, or that cost when x is 0, is 3. So if we look at this point right here, when x is 0, y is 3. Okay, so if we were to come up with an equation for this line, it would be y equals mx plus 3. Because if I put 0 in for x here, then this would in essence disappear and I'd be left with that 3, which is right here. So I also need to figure out what my slope is. So because I don't know what this constant of variation is, but I know that I can get this here from the graph. So I'm going to I'm going to find 2 points on the graph. So I have this one here at 0, 3, and I have this other point here at 1, 0, and I can calculate my slope. So I'm going to do my work over here. I'm just going to divide up this stuff. So I know that my slope then is equal to um, the difference in my y's all over the difference in my x's. So in this case, I look at my y's. I have 0 minus 3. So I'm going to do 0 subtract 3 all over the difference in my x's. So I started here with 0 and I'm subtracting 3. So for my x's, I'm going to do 1. So I start in the same coordinate, subtract 0. So 1 subtract 0. And so that's going to equal 0 subtract 3 is negative 3. 1 subtract 0 is 1. And when I simplify that, I'm going to have negative 3. So now I know that my slope is negative 3. So I can replace m, because m stands for slope, with negative 3. So I have negative 3x plus 3. And then I can just check that I've come up with the right equation. So let's take an x of 0. If I plug 0 in here, I have 3. Well, that's correct. Now let's take an x of 1. Well, negative 3 times 1 is negative 3, and negative 3 plus 3 is 0. So when I go to x is 1, yeah, y is 0. Try another one. Let's say x was 2. So negative 3 times 2 is negative 6, and negative 6 plus 3 is negative 3. So when x is 2, y is negative 3. Sure enough, when x is 2, y is negative 3. So I know that I have come up with the correct equation. So I can come up with equations from graphs, but I can also come up with equations from tables of values, because I know that every time I have a relationship where x is equal to y, in order to come up with this table of values, I have to know what y equals. Y is going to equal something times x plus something. And then I would just plug in 0 for x, and I'd be able to solve for these points. So I need to be able to work backwards. So just like over here, right, I know that I can figure out my constant of variation from here, and I can figure out my y-intercept from the graph, so my constant of variation or my slope and my y-intercept. I can do the same thing for my table of values. So every table of values has coordinates, and if I was to graph these, this would be one of the coordinates, this would be another coordinates with an x and y, this would be another one. So I can actually calculate my slope. So again, I'm going to say that my slope is equal to the difference in my y's over the difference in my x's. So I'm just going to pick two coordinates. It doesn't matter which ones you pick. You could pick this one, say, and this one. So if I pick this as the second coordinate, so the second y coordinate, and this as, sorry, this is the second set of coordinates, and this is the first set of coordinates. So now I look, and I say, all right, well, the second y coordinate is 4, and I'm going to subtract the first y coordinate, which is 3. So it's going to equal 4 minus 1. And then, because I started with 4 here, I'm going to do it over here. So 3 minus 2. So I'm going to take the second x coordinate, I'm going to subtract the first x coordinate. So then I do the math. So 4 minus 1 is 3, and 3 minus 2 is 1, and I end up with a slope of 3. So now I know that the number that I'm going to put up here is going to be 3. Well, the next thing I need to do is I need to figure out what my y-intercept is. Um, well, if I flip over this page again and take a quick look at these graphs, well, notice that here I have a y-intercept, and the x is 0, and the y is 3. And here I have a y-intercept, and the x is 0, and the y is negative 2. If I look a little further down, here I have a y-intercept, and the x is 0, and the y is negative 2. And here I have a y-intercept, and the x is 0, and the y is 2. So every single time I have a y-intercept, my x is 0. So let's take a look at the table. Do I have an x of 0 in the table? Well, I do. I know that x is 0 here. Well, that means that this has to be my y-intercept, because wherever it crosses the y-axis, my x-coordinate is going to be 0. So in this case, this is the y-intercept, so I can just plug in that negative 5 here, and so my equation becomes y equals 3x, and I have a plus and a minus, so I know that's going to be a minus, so it becomes 3x minus 5. And so that's the relationship I use to calculate the y-coordinates in my table of values. So let's just quickly check. If x is 0, I have 3 times 0 is 0, minus 5 is negative 5. If x is 1, I have 3 times 1 is 3, minus 5 is negative 2. If x is 2, I have 3 times 2 is 6, minus 5 is 1. If x is 3, I have 3 times 3 is 9, minus 5 is 4. So this is the equation that created this table of values. So we're just working backwards from it. Now, one thing you might notice though when you look at these tables is, well, here we have a 0, so we know that's our y-intercept. Here we have a 0, so we know that's our y-intercept. But the problem is here, we don't have any zeros, so we don't know what our y-intercept is. So that means we need to calculate the y-intercept. So I'm going to show you how to do that. So first, let's calculate our slope. So again, we can pick 2 points, and it doesn't matter which 2 we pick. So again, I'll pick these 2. So this is my second one, this is my first one. So I'm going to take the second y and subtract the first y, and I'm going to take the second x and subtract the first x. So second y is negative 43. And from that, I'm going to subtract the first y, which is negative 33. That's all going to be over second x, which is 9. Subtract the first x, which is 7. So negative 43 minus negative 33 means negative 43 plus 33. I'm actually going to write that just so that you have it in your records. So we have negative 43 plus 33 over 9 minus 7. So negative 43 plus 33 is negative 10. 9 minus 7 is 2. And so then this is going to reduce to negative 5. So I now know that my slope is equal to negative 5. So if I put an equation here, I'd have y equals negative 5x. Okay? So if you think of an equation of a line, it's always y equals mx plus b, where b is the y-intercept. So I'm going to actually write that here, y equals mx plus b. Well, y equals negative 5, because I know my slope was negative 5, x plus b. So what I need to be able to figure out is, what is that y-intercept? When this is going like 9, 7, 1, negative 2, I can't actually see a pattern. Well, I do know that I have one set of x and y coordinates. I have 2 sets of x and y coordinates. I have 3, and I have 4 of them. Well, here, I only need 1. I need 1 of the x coordinates and 1 of the y coordinates. So I'm going to take... I'm actually going to take this one because the numbers are nice and small, and so I can work with these small numbers a lot easier. So here I know my y is negative 3, so I'm going to replace y with negative 3. And then I know my x is 1, so I'm going to replace x with 1. Well, now I have an equation, and I can actually just solve it because I only have one variable. So this is just like we were doing last unit. So we know that negative 3 is equal to, well, negative 5 times 1 is negative 5 plus b. And so now I just need to add 5 to both sides. So I'm going to do negative 3 plus 5 is equal to b. And so 2 is equal to b. And so now I can put that y-intercept up there, and I know that y is equal to negative 5x plus 2, and that's what I've used to calculate this. So let's just check it. So here x is negative 2, negative 5 times negative 2 is 10, plus 2 is 12. That works. Here x is 1. So negative 5 times 1 is negative 5, plus 2 is negative 3. Well, that worked. So here we have 7. Negative 5 times 7 is negative 35, and negative 35 plus 2 is negative 33. So that worked. So here I have 9 times negative 5 is negative 45, plus 2 is negative 43. So that worked. So therefore I know that the equation that will give me all of these coordinates is going to be y equals negative 5x plus 2. And then I'm done. So I hope that helps.